I welcome you all to discuss the what is the difference between anode and cathode. In many terminology, the anode and cathode is getting confused while denoting the terms of positive and negative. So here we can see the battery electrodes is normally using the names of anode and cathode without specifying the battery is discharging or charging. Normally what happen, we have a confusion while denoting the terms anode, cathode, positive and negative, and finally we are determining, and we can finally come into the decision to say that it is a wrong terminology. So to understand the terminology of anode and cathode, here this video is going to be helpful to understand the terminology of anode and cathode and positive and negative electrode. While considering anode is an electrode, so in this case anode is an electrode means where an oxidation reaction takes place. It means that it is a loss of electrons. So the loss of electrons takes place, it means that oxidation. Here the cathode is an electrode where the reduction reaction is takes place. It means that it is a gaining of electron. So here the anode is an electrode now. It is, I can say, the loss of electron. Anode cathode is the electrode now. It is a reduction of reaction. It is a gain of electron. While denoting the battery terminology, you can see the same electrode will be used to denote both the reaction can occur where the battery is discharging or charging. When the battery is charging, we can define the terminology according to the positive or negative. Now we are in the battery, we can say naming the electrode, it is a positive one and negative one. While positive electrode is the electrode with higher potential than negative electrode. Considering the scenario during discharge process. Discharge means we are supplying the energy to the particular appliances. During that condition, the positive electrode is the cathode and negative electrode is the anode. While charging condition, if we are charging the battery, during the condition, the positive electrode is a anode and the negative electrode is a cathode. So here, the based on the charging and discharging, we are going to be decide which is a positive electrode and which is a negative electrode. There is a not a constant electrode. I can say cathode is a positive or anode is a negative, or anode is a positive or cathode is a negative. We can't able to define that it is a constantly, the name cannot be given to anode or cathode. It depends on the reaction which is going to be happening in the places. Now you can consider this equation. So when an oxidation reaction happens in the nickel zinc battery, if I am considering a nickel zinc battery, here the oxidation process happen for the zinc metal. So what happened is that 10 plus 4OH, it finally what happened, it is converting into the zinc OH 2 minus 4 plus 2 minus 2E minus. It means that this is a loss of electron. When the, it is a equation determines when the oxidation takes place in the particular metal, here the loss of electron is takes place. Loss of electron means we can say here the loss of electron, it is higher potential than the negative electrode. So likewise here the discharging processes takes place. If the discharging processes takes place, the positive electrode is called as a, if discharging takes place means the positive electrode is cathode. While charging, it means that here you can consider there is a loss of electron. Similarly, I can say that So here you can see that next equation we can say that from the lithium ion battery. In lithium ion battery, I am considering the discharging charging process. While charging process means we are saying that that is the gain of electron. Gain of electron means, for example, lithium minus COO2 plus LXI plus XC. That is the addition of electron to the particular compound. So the compound is getting recharged. So this is called as a process of charging. During the process of charging, what happen? It is a gaining of electron is going to be takes place in the battery surface. So that is a based on the reaction we have to determine anode and cathode in the batteries. Okay. While you can see this graph, this is an anode and cathode graph. When anode is an electrode where oxidation reaction takes place, you can see oxidation reaction is takes place. The potential of anode is through which the current is flowing higher than the equilibrium potential. Equilibrium means this is a zero. When oxidation is takes place, the current flow is higher than the equilibrium potential. So that's why we can say that is oxidation. While we can say consider the cathode is an electrode where reduction reaction is takes place. When the reduction reaction is takes place, this is a equilibrium position. The current flows in lower than its equilibrium potential. So that's why the graph has the oxidation reaction and reduction reaction. When oxidation is takes place, the current is higher than the equilibrium potential. Equilibrium potential, it is greater than zero. When the reduction reaction means the current is less than the zero, where the current is lower than the equilibrium potential. It means the current flows below the equilibrium potential. So that is a cathode. Now you can see the positive and negative electrode. In positive and negative electrode, we can say it has a different potential. The electrode with higher potential is referred to be the positive, and the electrode with lower potential is referred to be the negative. For example, positive, I can say higher potential means it is say the flow of electron from plus to minus. It is a higher potential, and negative is a lower potential. When the electrode has a higher potential, this is called as a positive electrode. When the potential electrode has a negative potential, it is called as a negative electrode. It is the terminology while we are using in batteries, because we are doing the charging and discharging process. It is an irreversible process is going to be takes place. Now you can consider the electromotive force. The battery is the differences between the potential of positive and negative. So only we can refer all the batteries in terms of voltage. At the same time, the discharging rate of the current, we can say the electron is flowing out from the battery. So the battery rating is given in terms of ampere hour. So the rating of the battery, we can say that in ampere hour. And the electron flowing from a higher potential to lower potential. So the difference between the potential of positive and the negative electrode, we can say the electromotive forces. This is a simple logic behind the electrodes. Now you can see this diagram. Here the battery operation, you can see the E plus, it is a E plus is a reaction. It is a positive electrode, and this is a negative electrode. Now you can see when the positive electrode is started to getting discharged. Here the position is going to be getting discharged. So during this condition, the positive electrode is a cathode and negative electrode is a anode. Once the discharging process is over, it reaches the equilibrium position. Again, it starts to charging. So during the charging potential, you can see the positive electrode is the anode and negative electrode is a cathode. So this is a way we have to define the name of positive electrode and negative electrode. You can listen here. The positive electrode means when the current is getting discharged to the equilibrium position, During that time, the positive electrode is the cathode, negative electrode is the anode. Once the charging is completed to the particular cycle, again the charging cycle is going to take place. During the charging cycle, the positive electrode becomes anode and negative electrodes become cathode. So this is a operation, this is a process will happen in the charging and discharging of the batteries. Here you can see the discharging process. The cell voltages become reaches to the value of that is a equilibrium position, not zero. It is above the zero. Here we can say the difference between the positive and negative. Accordingly, the voltage is going to be get increases. So the U is the differential voltage across between the positive electrode and the negative electrode. That is the equation represent here. U is the potential between the positive electrode and negative electrode. So the potential is getting decreases. Again, the potential is getting increases during the charging period. So this is a basic of battery operation. Either any kind of material we can use. So it is you have to understand this terminology. The positive anode, positive, negative, anode and cathode. It depends upon the charging and discharging cycles. Well, you can see here. So the discharge, you can see the battery diagram here. So this is a discharging diagram. This is a charging diagram. While the discharging diagram, what happened? You can see the plus, the electron is moving from load to cathode. Here the electron is moving from electrode to cathode. So here the positive is cathode, negative is anode. During the charging cycle, you can see the electron moving from positive, that this red color electrode, to negative electrode. So when the electron moving from positive, the red color to negative electrode, it becomes anode and the negative becomes cathode. So this is a simple understanding between the anode cathode. Okay. So in this lesson, what we have learned means you have to understand the basic reaction of anode, cathode, positive and negative. So while we can say that the conclusion, on other hand, the role of each electrode is switched during the discharge and charging cycle. During the discharge, the positive is a cathode, negative is a anode. During the charging, the positive is anode and negative is a cathode. Okay. So don't say that the cathode is positive and anode is negative, or anode is positive and cathode is negative. It is applicable. If I say the cathode is positive, means it is applicable only for the battery which is going to be only have the discharging cycle. When the battery has both the cycle, it is going to be switched between the operations of normal rechargeable batteries. Thank you.